We'll proceed in pseudo calculus problems. Okay, so we are pursuing discussion on pseudo calculus problems, and it looks like it is really tedious. It is not that straightforward calculating the kind of normal calculus. Anyway, what we have learned till now, we have already talked in the prior session. There are two calculus. One calculus is called primitive calculus. Okay, and one calculus is called modern calculus. In modern calculus, everything what we do is through delta x, delta y. This is what we are trying to do right now. And primitive calculus, everything we do from the algebra perspective, where we understand that what is calculus. Calculus is like a multiplication only, where we try to find a multiplication of two items where one item is dependent upon other item. The independent item we place d mark out there and it becomes integral calculus, like y into x becomes y into dx, where y is dependent upon x. Y by x, simple division, becomes differential calculus when numerator y is dependent upon x. In that sense, y by x would become dy by dx. How much is the y per unit x, that is y by x? This definition would transform into how much change in y we see if there is a unit change in x, dy by dx. Okay, so we say that multiplication, we say multiplication is nothing but repeated addition. Y into x is nothing but y plus y x times. That is y into x, y plus y x times. So repeated addition in multiplication. Sometimes repeated addition is not required, but addition, summation, it brings to integral calculation. Again, y plus y x time says y into x. Okay, now if y is dependent upon x, then it becomes y dx. Okay, this is this is repeated addition. Y plus y x time becomes y into x. Repeated addition becomes becomes it becomes multiplication. This is normal mathematics. Repeated addition, that is y plus y x time becomes y into x. If y is dependent upon x, then x is independent component and y is dependent upon it, then y into x becomes y dx. Now, now multiplication transformed into integral calculus. Anyway, now we will see more thing. What we are seeing through the summation. The repeated summation also becomes integral calculus. Consider this is x-axis. Consider this is x-axis. If this is x-axis, then here this is origin. This is x-axis and this is origin. If this is origin, consider I have a line from 0 to x. I have a line from 0 to x. Now I divide into n part. I have a line on x-axis 0 to x. This is x-axis or I vector. So in that sense, I have a section on x-axis 0 to x. This section I'm dividing it into n part. Okay, then first section, second section, third section, fourth section, and then the last section, nth section. If that is the case, consider the width of first section is delta x1 or y1. That is not true in this sense. Delta x1, delta x2, delta x3, delta x4, delta xn. Now I can write summation of I, summation sign, sigma sign, this, this, this. Summation of I equal to 1 to n delta xi is superscript, bottom right side, delta x bottom right side, small I, delta xi, if I do like this, then it becomes like a if someone add I plus I equal to 1 to n delta xi, it becomes 0 to x because I had divided x into n part. Now the people would think that delta xi means all delta x are equidistant and 0 to x is divided into the n part. Someone can say delta x is the width of one section where all sections are of same width. Delta x into n equal to x. Makes sense? Means n equal to x by delta x. Consider delta x, all delta x, the section in which I divided 0 to x in n part. All parts are not same gap. All parts are not of the same width. Delta x1, delta x2, delta x3 are independent of each other and they have different length, but they are non-overlapping. That is for sure. Still, we can say summation of I equal to 1 to n delta xi equal to x. Anyway, this kind of scenario, this repeated summation, sometimes it leads to integration. Okay, if I say y into x, where x is independent component, y is dependent component, then it also leads to integral calculus y into dx that many times we have seen. Anyway, y into x is also y plus y x time. Then it becomes repeated. Then I would say summation of I equal to 1 to x, because it is x time y. This also becomes y dx. Makes sense? Okay, two forms of integral calculus. Why we are saying this? How we can solve a mathematical problem? If I am going to solve a mathematical problem, then I may be provided with the real life example. This is inductor, this is capacitor, and this is how electric is charging into inductor capacitor. Without considering that how you will solve, you will use a vector or you will use calculus, algebra, whatever it is. If you are using calculus, algebra or whatever, there will be a one point where you will think switching it to calculus, that we are talking. If you are writing something like y into x in an expression to calculate y into x, all of a sudden you see that y is dependent upon x. Y and x are tied to each other. In fact, y is function over x. In that sense, fx into x will not be normal multiplication. If fx is x, function over x is x, then fx into x is x into x. That is not x square, that will be x squared by 2. It will follow integration. Y into x, fx into x would get transformed into fx dx. Similarly, if I say that I have lot of delta x and if I add it, I equal to 1 to n delta xi, if I add all delta x, it becomes x. In that sense, where all delta x are not overlapping to each other, in that sense, we can transform into dx. All delta x summation, that summation of all delta x, where delta x1, delta x2 to delta x, they may not be of the same length. Still, we can say I equal to 1 to n delta xi. If repeated addition is there where they are not overlapping, then typically we can write it as dx. Dx limit is 0 to x. Okay, or I can write y into x as y plus y plus y plus y plus y plus y plus x time. It is same as summation mark I equal to 1 to x time y or yi. This will be converted into y dx. Hope. Okay, or no, you said that delta x has to be there in the summation. Then only we can convert into dx. Who is stopping you? Who is stopping you? Okay, but this is not the same. Del summation of I equal to 1 to n delta xi tends to dx. Okay, but you are saying summation of I equal to 1 and then up to x time yi is y dx, where dx came. Okay, someone can write it again it as summation of I equal to 1 to x yi into 1. That's yi into 1. Same. Now 1 I can write as delta xi. Now it is summation of I equal to 1 to x yi into delta xi, where delta xi, all delta x are 1 only. Now it will be transformed into y dx. Okay, these are the concept. I want to say these are the new concept our all ancestors they were using this form of repeated summation and integral calculus. Anyway, we left our discussion in the area calculation and perimeter calculation that we are watching very closely. That how to calculate the perimeter of a circle and how to calculate area of a circle. How we calculated perimeter of a circle. Hope, hope, hope. How we calculated perimeter of a circle is this is the circle and we want to calculate perimeter of a circle. If I want to calculate the perimeter of a circle, consider this is x-axis and this is y-axis. This is centered at the origin. This is x-axis and this is y-axis. This is centered at the origin. If it is centered at the origin, now this is x-axis, this is y-axis. Anyway, now this is circumference. I want to calculate the circumference. If I want to calculate the circumference, then I can divide the circumference or the closed arc that is closed. I can divide the circumference into many subsections, one subsection, two subsection, third, fourth, fifth, sixth, like that, into n parts. Consider the length of one subsection. Length of one subsection is AI, arc, arc, AI. Okay, this is not area. Or if someone has confusion, PI, perimeter I. Pi. Now I can say the perimeter of a circle is summation of I equal to 1 to n because n part I have divided. I equal to n Si S and bottom right subscript as I. If someone adds SI, S1, S2, S3. This is section 1, section 2, section 3. I mean PI, perimeter I. Perimeter 1, perimeter 2, perimeter 3, like this. If someone add I equal to 1 to N, PI, capital P and bottom right I, PI, it gives the full circumference. If someone add it. Now I have to place PI in a form that quickly I can convert into integral calculus. What is PI? If I talk about the ith section, okay, so this is the first section. What we're going to talk is $1 trillion explanation. These are not available in the book. Okay, like if I talk about the circle, then this is x-axis. Up, up, up. If this is x-axis, if this is x-axis, then this is the first section. Okay, if this is the first section, then this is the second section. Like that, consider I have the nth section, ith section, where it is divided into n section. Each section has parameter pi. Now I am into the ith section, and this is the parameter or this is the arc. What is the length of this arc? If I get this length of this arc, then for all sections, if I get the parameter. What we did in the previous time we did that to get the n, anyone would reply quickly that this is nothing but r. What is your angle between it? Since this is ith section, I say angle between it is delta I, delta theta I, delta sine, theta sine, bottom right small I, delta theta I. This is the ith section. Okay, then if this is r, then this arc will be r into delta theta I, but we cannot take it because r may be function of theta. This is what we are saying. Okay, like r equal to cos theta. If I say r equal to cos theta, it will again draw a circle. Okay, if r is 4, constant, not function over theta, then it will draw a circle like this, which is centered at the origin. This is origin. Then there is a circle centered at the origin. It has radius 4. R equal to 4. Theta will vary. Zero angle 0 to 2 pi. Okay, if I say r equal to cos theta or r equal to 4 cos theta, if I say r equal to 4 cos theta, then radius will start from here. Where is the another one? Okay, looks like another one is missing. I'll use this pen. Okay, so it is something like if I have like this is the origin and this is x-axis, y-axis, and in that fashion, if there is a radius r equal to 4 cos theta, when angle is 0, radius is 4. Now radius is moving because angle is moving. I'm sorry. Now angle is growing from 0 degree angle is growing and radius is changing. Now radius is decreasing. When angle is 90 degree, radius is 0. So radius started like this and it came like this. When angle is growing above 90 degree, then radius to grow start growing again, but radius will become negative. To get the radius positive, we will see the other side of the radius, 180 degree from this. This is negative, then this is positive. Okay, if I say this is my radius, positive radius, this is your negative radius from. So if I go beyond 90 degree, radius will start growing for cos theta, but it will grow in reverse direction as positive. Means it will fulfill a curve like this. It will be a circle now with angle pi, not 2 pi. 2 pi is the circle angle full, but this r equal to cos theta or r equal to 4 cos theta, the angle is 0 to pi, it makes the half of the circle, and then pi, I'm sorry, 0 to pi by 2, and pi by 2 to pi, it makes the full circle, r equal to cos theta. Okay, in that fashion, I cannot say, no, this is, we are talking about the ith section of the parameter. Ith section of the parameter has angle delta theta I. Now this arc, what we are talking about, this arc, ith section we are talking. Now this arc, the arc, what it will make, the length of this arc of the ith section will be r delta theta I, not true. Because radius is not constant. Here radius is this. And if I move delta theta I, radius may shrink like this, because radius is a function over theta. R theta I is arc, that is true, but where r is constant, if r is varying, just think about it. R theta I is actually this arc, whereas if r moved delta theta I, r started shrinking, it came to this, it may become 0 also. If it becomes 0, then arc will be a r only, the straight line will be the arc. So r delta theta I is not r. So we cannot use this fundamental. What we did is that we took this point, one point here and one point here. Consider this point is x2, y2, and this point is x1, y1. This is x-axis. In that fashion, if I move this radius from here to here, I'm sorry, move this radius from here to here, it makes delta theta I angle. In that fashion, the delta x is shifting. This is polar coordinate system. Radius and angle theta comes under polar coordinate system. But we are drawing this polar coordinate system on top of Cartesian coordinate only. If this is x-axis, this is y-axis. Can you see all four things now? X-axis, y-axis, radius, angle. This is hybrid model. Anyway, if someone is moving from here to here, here the intersection on x-axis is here. If I take ith section, this is the first section, second section, ith section. Now intersection of this axis is here. This is x2, then this is x2. This is x1, this is x1. How much it moved? It moved delta x. Similarly, it moved delta y. Delta y equal to y1 minus y2. Delta x equal to x2 minus x1. It moved delta y and delta x. When it moved in ith section, radius is moving like this. This line, what we are talking, this line may be like this also. When radius is decreasing, if I move the angle, this line is delta x whole square plus delta y whole square root, because this becomes a hypotenuse, and this is delta x delta. This is perfect, and we proceeded in calculating this. What is the curve line for the perimeter ith section? The ith section perimeter is delta xi whole square plus delta yi whole square root. What is the full perimeter? That is summation of I equal to 1 to n square root delta xi whole square plus delta yi whole square. Now this will be transformed into integral square root dx square plus dy square. This we have seen. Okay. Now question what is arising, that what about calculating the surface area of a circle? If we are calculating surface area of a circle, then again we will divide the circle area. Earlier we divided the perimeter of the circle. The perimeter of the circle we divided into n parts. Now we will take area. Consider this is the first area. This is the area. This is the area. First area. This is the second area. This is a wedge kind of shape. This is the second area. This is the third area, fourth area. Like that we have n area. What is the net area of a circle? That is summation I equal to 1 to n. Summation I equal to 1 to n a, and then subscript is I. Capital A bottom right is I. Summation of I equal to 1 to n ai. This is the net area. Now think about the ith section. Now this is the ith section. This is the ith section. If this is the ith section, what is the area? We can write here. We wrote like 1 by 2 r square delta theta I. This is the delta theta. This is the delta theta angle between it. It is 1 by r square delta theta I. Now we can write is summation I equal to 1 to n 1 by 2 r square delta theta I, where r is function over theta. R is changing if I move the theta. If this is x-axis, then at any moment this is at angle theta. This is delta theta. At this moment, this is the r. R is a function over theta. If it is function over theta, f, small f or capital F, generally people use here capital F. Capital F bracket theta bracket close, or small f bracket theta bracket close. Radius is function over theta. In that fashion, if it makes theta angle with the x-axis, what is the radius? Then this radius is function over theta. What is this radius? This is theta and this is delta theta I. Then it is function over theta plus delta theta I. What is the area here? Then what we talked is that we will draw this is R1. R1 is function over theta. Considering this is angle with the x-axis as theta. This is R2, function over theta plus delta theta I. This is delta theta I. Okay, but at the end, both are function over theta, where theta is variable. If I say theta is constant and this is a fixed theta, then this is f theta. And this is fixed theta plus delta theta I, then it is f theta plus delta theta I. This is R1 and this is R2. This is the R. But this R2 can be smaller also, because radius is varying as we move the angle. Anyway, what is the area of this? If this is the arc, if this is the arc of the circle, what arc can be like this also. We drew a circle from the x, r equal to cos theta is the equation of a circle, where circle is like this, not like this. This is r equal to some fixed value. If r equal to cos theta, this is the circle. If this is the circle, then radius will start moving like this. When angle is 0, radius is like this. Radius start moving like this when angle proceeding. But radius starts shrinking. And when angle is 90 degree, radius is becoming 0. In that fashion, this is the ith section I am talking. This is the first section, second section, third section. This is the ith section. This and this. Between these two, I have ith section. What is the area of ith section? This is the arc, what we are talking about, the ith section when we are calculating the area. Certainly that arc is not for a circle that is centered at the origin. That arc is different, where this radius is larger and this radius is smaller. How we calculate area of this? Then we say, consider this arc is going and falling here. It makes 90 degree here, considering this angle is very small. In that fashion, this radius into this arc are 90 degree to each other. Then this form a triangle where this side and this side are perpendicular to each other, and they make a right angle triangle. In that fashion, this will make a rectangle. Consider this line, this line, this line parallel to this line, and this line. It make a rectangle whose area is this line into this line. Then the area of this triangle is this line into this line by 2. That is R2. This is R1, R2. R R1, sorry, R2 and into this. If this is R1, then this is R1 delta theta I. How you can say? You did not say this in the while calculating the parameter. Assume like that. This is what I don't like. Assume like that. Assume that it is so small that this line will be R1 delta theta I. Now the area of the triangle is half into R2 into R1 delta theta I. R1 and R2 are function over theta. I can write 1 by 2 R into R delta theta I. Net area is summation of I equal to 1 to n 1 by 2 R square will be function over theta delta theta I. It will be transformed into integral calculus as 1 by 2 integration over 0 to another angle r square d theta, where r is function over theta. Okay, here r equal to cos theta, cos square theta d theta. Makes sense? Summation of I equal to 1 to n, 1 by 2 r1 into r2, sorry, r2 into r1 delta theta I. If I say r2 and r1 both are variable theta, function over theta, it becomes 1 by 2 function over theta into function over theta delta theta I. If I say function over theta is r only, or leave it like that, function over theta, then this summation I equal to 1 to n, 1 by 2 function over theta into function over theta into delta theta I will get converted into integration of theta from 0 to something, and then 1 by 2 function over theta whole square delta theta d theta. Now, function over theta is cos theta. 1 by 2 I can keep outside, cos square theta d theta. Angle is going from 0 to pi by 2 and then pi by 2 to pi 0 to pi, function over theta whole square d theta, cos square theta d theta. Cos square theta integration is theta by 2 minus sine 2 theta by 4. 0 to pi, it will become pi by 2. 1 by 2, pi by 4 is the area, certainly. If this is the circle, and if this is a circle of radius 1 by 2 and centered at 1 by 2, if radius is 1 by 2, this is what someone can draw r equal to cos theta. It will lead to a circle that will have form of x square minus, x minus 1 by 2 whole square plus y square equal to 1 by 2 whole square. A circle that is centered at 1 by 2 comma 0 and which has radius of 1 by 2. The area will be pi r square, pi into 1 by 2 whole square, pi by 4. But people would say it is not satisfiable. The way you are saying that the ith perimeter is delta x whole square plus delta y whole square, or delta x I whole square plus delta y I whole square root, it is more or less satisfiable. But area under the any ith section is 1 by 2 function over theta into function over theta delta theta is not satisfiable, will make you satisfiable. Okay, what is the other way we can calculate the ith section parameter? Consider there is a point here, and we take origin like this only. Okay, this is the x-axis and this is y-axis. Consider there is any point here called P. Point here for P. P is x comma y. Makes sense? This is position vector for the P. This is origin and this is P. That is xi plus yj. Okay, this is at angle theta from the x-axis. Makes sense? This is at angle theta from the x-axis. Then up. There is a point here called x comma y, angle theta. Now, if I move theta 1 unit, now position vector change. Earlier this point was x comma y, the new point is x2 comma y2. How much position vector is changing if I am making 1 unit of angle change? Consider I moved here this as delta theta angle. What I am trying to say, how much position vector is changing if 1 unit of angle I am changing? Position vector is changing because radius we are changing. Anyway, the line that was connecting origin and any point here x comma y is called position vector. Now I moved it 1 unit and its next point is x to y2. Moving 1 unit is not possible. I can move delta theta angle. Then if I move, then another point it is checking x to y2. How much this point or position vector change if I subtract this position vector? This is P position vector xi plus yj. This is P2 position vector x2i plus y2j. What is P2 minus P1? That is the change in position vector I am seeing. If I subtract two position vector, then it will be position vector like this. Anyone can see in the vector rotation. If I subtract this line vector to this vector or this vector to this vector, it will be a connecting vector like this. Okay, if I add this vector and this vector, then there will be an in-between vector that will pass like this. But if I subtract this vector and this vector, there will be a connecting vector like a tangential vector, whatever it is. What is difference in what is P2 minus P1 by delta theta? That is per unit change. P2 minus P1 happened because I moved delta theta I. because of delta theta I, x1, y1 change into x2, y2. x1, y1 is p1, x2, y2 is p2. Now, if I move delta theta, then position vector change from p to p2. How much position vector is changing if I make 1 unit of angle change? That is p2 minus p1 by delta theta. Make sense? What is p2 minus p1 by delta theta? Change in p by delta theta. dp by d theta. Up, where delta theta tends to 0. dp by d theta, dp by d theta. This is the change in the position vector. We see change in the position vector. We see per unit change in the delta theta. Okay, but someone would say change in the position vector I can write as d of p, not required d of by d of delta theta. Now you can write d. I'm sorry. If I say I have a position vector, if I have if I have a position vector, if I have a position vector, it can be written as p. Change in position vector can be written as d of p. D of p can be written as d of p by del d theta into d theta. Now this is change in position vector dp by d theta. Okay, but it will be written as dp by d theta into d theta to make it complete. Makes sense? Change in position vector can be written as d of p. Position vector can be written as p. Change in position vector can be written as d of p. D of p can be written as dp by d theta into d theta. More or less, it came as how much position vector is changing because of change in delta theta. If I multiply by delta theta, I can see the net length. Makes sense? Y by x, y by x, I'm sorry, y is nothing but y by x into x. But if I calculate y by x or dy by dx, it tells me how much y is changing per unit change in x. I would rephrase it. Y equal to y by x into x. Makes sense? Y equal to y by x into x. What is y by x? Y by x is nothing but per unit of x brings how many unit of y? Y by x. If I have y by x, I get, if I multiply it with x, I get back the y. Similarly, if I have dp by dx, the way we started the discussion, dp by dx, that is p2 minus p1 by delta x, per unit change in delta theta, dp by d theta, dp by d theta, p2 minus p1 by delta theta. If I move delta theta change, then how much position vector p is changing to p2? p2 minus p1 by delta theta. Per change in position vector when we make delta when I'm sorry. Okay, this is x comma y. This is x2 comma y2. This is position vector p. This is position vector p2. Okay, it happened because I moved angle from here to here. That movement of angle is delta theta or delta theta I if it makes ith section. Now I am saying how much position vector change if I make 1 unit of change. If I want to know, then this is a clear example that position vector change from P to P2, P to P2. When I make angle change at delta theta I can write as P2 minus P1 by delta theta I. It gives me how much position vector changes when I made delta theta I change. That is equal to how much position vector would change if I make 1 unit of angle change. This is the change in position vector, but I want this length, right? Ith section length. This is change in length. If I multiply it back by delta theta, it will give me the exact length. First, the rate of change I am getting. P2 minus P1 by delta theta is the rate of change, or if I talk in calculus, then it is the rate of change. How much position vector is changing if I make a 1 unit change in angle, that is same as P2 minus P1. We want to calculate how much position vector is changing. Position vector change is the arc, because subtraction of two vector will give me this vector, that is the arc vector. Makes sense? That is the arc vector. Anyway, the question arising is if I want to see that if there is 1 unit of delta theta change, when the angle is this, that is theta, and then theta is growing like delta theta. If theta is growing 1 unit, I'm not saying delta theta. This is x-axis and this is radius. Radius is cutting this arc at point x comma y. Now, this is the red position vector called xi plus yj or p position vector. If I move one theta angle, 1 unit of angle, it will touch the arc at another point, other point. Now I am saying this position vector, how much position vector change when I move one angle, when previous angle was theta from x-axis. To calculate that, I have x comma y. I moved delta theta I, and another point is x2 comma y2. This is p and this is p2 position vector. If I subtract p2 minus p1, p2 minus p, I know how much position vector change, but it changed because of delta theta I change. P2 minus P1 by delta theta I is change in position vector because of delta theta I. This is change in position vector. Change in two vectors. If this is the vector, this is the vector and this is the vector. Subtraction of two vectors is another vector along like this. That is the arc. We want that arc, but we got the change in the arc. dp by d theta is a change in the arc. We have to multiply with the d theta to get the arc. Makes sense? This is the actual equation to get the arc length of the ith section. dp by d theta, where theta, dp by d theta, where theta is for the ith section, with entering the ith section. What is the theta it is making with the x-axis? dp by d theta into d theta. But this is the magnitude we have to calculate for dp by d theta, because we want the arc length. Arc length, if I say dp by d theta, then it will to tell me the change in the position vector when there is a 1 unit change in the theta angle we see. But change in position vector, that is p2 minus p1, will give me another vector that will be along the arc. We don't want vector, we want the magnitude. Means dp by d theta magnitude, if I calculate dp by d theta magnitude, we calculate, we will get something like rate of change magnitude, or dp by d theta into d theta. If I say, then it will give me the arc length in a vector. If I calculate magnitude of it, we'll get the arc. dp by d theta into d theta magnitude will give the arc length, or we can say dp by d theta magnitude into d theta. It will give the arc length. Similarly, we will try with the area also. Okay, now we have the ith section. Consider that this is the arc of this ith section. There is any point on this. This is the ith section. We are trying to calculate the ith section area. Now calculate any point P here. Similarly, if I say dp by d theta r, then it will tell me how much area is changing if I'm moving 1 unit in theta r area into d theta r. Makes sense? Any point can represent a line. Any point can represent a surface. Any point can represent a volume, whatever it is. I mean, any position vector. If there is a point called x comma y, and if I draw a line from origin to x comma y, that is called position vector. If I say that I have a position vector on the circumference, then this position vector represents a line. It represents a curved line. If I say I have a position vector on this surface, this is a surface, on top of it I have a position vector. If if position vector means a line connect from origin to that point, if that is xi plus yj, then this position vector represents area. Depends upon what is the type of position vector. Now I am trying to find the area of the ith section. Area of the ith section. Consider any point P here, that is xi plus yj. Now if I say, now I am trying to find the area. If I say if I move 1 unit of area change, earlier it was 1 unit of angle. If I change, then how much position vector changes? Now consider this is xy plane. This is xy plane. There is another plane called theta r plane. Make sense? This is xy plane, and there is another plane called theta r plane. Xy plane, theta r plane. They are mapped with a function that x equal to r cos theta, y equal to r sin theta. This is how they are mapped to each other. Now what I'm trying to say, that how much position vector would shift if I make 1 unit of area change. 1 unit of area change in theta r. Earlier we said how much position vector would shift because we are trying to calculate the ith section circumference. Now we are trying to calculate ith section area. Now, if I say there is a position vector P on the ith section area, then how much position vector would shift in area? In area, if I shift theta into r as 1 unit, makes sense? This is even simpler. How much position vector would shift in area if I shift theta into r as 1 unit? Theta into r, there are two components here, theta and r. They constitute an area because if you multiply two components, it will constitute an area. Means if I make 1 unit of area change in theta r, how many unit of area change I see in P? Okay, this will be change in the area in the P with 1 unit area in the change. Now, if I want to calculate that area, then I have to calculate the area, not change in area. For that, I need to multiply with the theta r. Makes sense? If P is a position vector on area, and if I say dP by d theta r, dP by or P by theta into r, that will tell that how much position vector is changing in loose term. Division is not change, but anyway, loose term, how much position vector is changing in area fashion. If there is 1 unit of area fashion, I see change in theta into r. Now I get change in area because position vector is changing in the area per unit area change in theta into r. Now if I want to get the net area, I have to multiply it with the theta into r. So net area of the ith section is dP by d theta r into d theta r. Now now, this magnitude, because that will again come as vector only. Now, if I calculate the magnitude, we will get the net area of the ith section. What is the net area of the ith section? What is dP by d theta r into d theta r? This we will see in the next section. dP by d theta r into d theta r. Magnitude of dP by d theta r into d theta r. D theta r will come out and it will become dP by d theta r magnitude because it will result in a vector into d theta r. What is this vector? This is called change in the area vector that belongs to P when there is 1 unit change in the area vector in theta r and then magnitude into d theta r. It will come as 1 by 2 r square. It will come as r dr d theta. Someone calculate. It will come as dr r dr d theta. R dr is r square by 2. It will come as 1 by 2 r square d theta. If I see this integration from the summation perspective, then this is exactly the representation of ith section area 1 by 2 r square delta theta I. We will see more on it. Means indeed the area of the ith section is 1 by 2 r square delta theta I from the vector perspective. Okay, this way also we can calculate what is the ith section length or ith section area, ith section volume or whatever it is. Then we can go for the summation and we can transfer back into integral calculus. Someone can say this is a method of verification also that ith section area we had taken in delta theta, it is really right or not. Anyway, please, these are not available in any of the book. Anyone can try. Please do not mind supporting us. +91 is the India country code 9483160610 is the telephone number. +91 is the India country code 9483160610 is the telephone number.